Hello and welcome. Okay, so I might as well put in a little plug for PixArk. I've been watching Zul'jin play PixArk on YouTube for quite a while now, True Confessions, and so I decided to purchase it. I just bought it, and it's going to be in my arsenal, so you might even see some streams of it on my channel in the future. Anyways, kids, back to OpenGL. Okay, what we're doing today, kids, let me tell you, let me show you what we're doing. Okay, so I went with one of these projects, 7.4, I guess, the camera project. Excuse me, what I did was I have been experimenting with instancing, which I've done before, but in the 2D, we're getting into 3D now. So basically what I wanted to do was have all of these cubes drawn, instanced. The cubes are set up in this vertices array, so they're negative zero point 0.5 to zero point 0.5 cubes. So it's basically 1 is the size. So when I went into the drawing code, draw arrays instant. Okay, so I just had 100 instances of the triangles sent through, and I discovered, of course, rediscovered, I should say, this GL instance ID. So for every instance that the Vertex Shader runs through its course, this goes from 0 to 99. Okay. So long story short, the mod function wouldn't work for me. So I came up with my own mod, of course, with the fract, using the fract. So I take the instance ID, which goes from, hey, don't do that. Stop right there. Stop it. Okay. So this goes from 0 to 100, right? So you divide by 10. So as it goes from 0 to 9, this is 0, with a fraction part left over. So I just subtract the fraction. Okay, so it's just a flat 0. And then as it goes to 10, 10 through 19, it becomes 1 point something, minus the point something right here. Okay, and on up and through all the way up to 99. So for each of those little levels, this is our x. Okay, what I wanted to do was set this in here so that each cube is drawn 1.2. Each cube starts to be drawn, like, let's say here, and then 1.2 later, and the other one draws here. So there's a 0.2 space in between each cube that you see. And then this is the same for the y. Okay. And then after you get through your first row, right, like the first time you go through 0 through 9, this is 0, right? So you're taking 0 minus the fractional, so it's all, this is all 0, everything in these parentheses right here. Oh, why? Visual Studio. Maybe it's my new mouse, but I blame Visual Studio. Okay. Anyways, so this goes to 0. Okay. So 12 times 0, 10 times. And then once it gets to the 1, so in other words, this is 10 to 19, then it's 10, which is 1 minus the fractional part. So then this just gets reset. So it goes do 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 do, and goes, oh, we're out to 12. Let's subtract 12 and go to the next row and the next row. And then y just keeps going up because this is just the mod. So like this 0 to 9 is 0 minus the fractional, so that's 0. All the way up to 10 until it's 1, and then so y is just going to keep going up and up and up. So that is why when we get this cube shape, the square shape, you see right down there in the corner, and then x goes across, and then on the next row subtract 12, and the y goes up, and then the same thing on the next row, and the next row, and the next row, and the next row, and the next. Okay. And then what we do with, let's see, the position is basically just this. I just took out the model transformation because what the program used to do is this is the cube positions, the one where he puts that in there, and that's the and I commented out the model transformation because we just want the projection and the view transformation applied to each one. We don't want the model transformation applied. So I just do that projection times view times position. Okay. And you notice that I had to create a new variable because you cannot alter incoming. You can't alter incoming data apparently. So new position equals a position. So as it comes in, it gets set to this variable, and then we go through the x and y thing, and then it gets set to the output right there. And then the texture coordinate is right here. See? So I basically just do this with the texture coordinate. So the x just goes across. X is just like that. The x is just chilling out right there like that. But the y, you see, uses my mod function. So it just incrementally goes up. Why does that work? I wonder why that works. Does it actually work? It works, doesn't it? Huh. I wonder why. Yeah, so anyways, what I wanted to do now, and of course because I wanted to challenge myself, and I'm downloading PixArc, which is going to take another 20 minutes, so I figured I'd challenge myself with the program. What I wanted to do is create a new thing. I'll show you right here. This is what I meant. A new vertex or trib pointer. Okay, so we have the texture coordinates, which we don't use. we don't. We don't. Or actually we do. Sorry. Take that back. We do use them. It's just that they get modified on the way through right here. The texture coordinates are modified right here. So that, and we modify them in the Vertex Shader so that they will interpolate across the vertices. And because I remember the first time I tried this, I tried to do it in the Fragment Shader, and I wasn't really thinking about stuff right, so it was confusing. Yeah, not confusing anymore. And of course, the real reason why I wanted to do this was because I have this. And I wanted to use one texture, which this is, and get 100 textures out of it, which I just did. So all I have to do, basically, because the texture is based on the instance ID, because this is the program is actually running a pattern. This is all procedurally generated. The positions are procedurally generated, and the texture coordinates are procedurally generated. So there. Okay, I'm procedurally generating stuff. Okay. No, so I don't want to procedurally generate those in the Vertex Shader anyways. What I want to do, and I may be crazy for wanting to do this, but I want to go up into here, the vertices. Actually, I just want to make a whole new thing here. Hold on. So first of all, let's just try this, because we know that the what do we have here again? See, we have the position, which is based on the instance ID, and then we have the texture coordinate, which is based on the instance ID. So if I throw in just one number, because the GL instance ID, actually, you know what? Maybe I should probably confirm that and look it up. Hold on. We are going to confirm it and look it up. Built-in GLSL variables and functions, page 693. Bear with me here for just a second. Okay, GL instance ID. I found it right away in 698. Okay. The Vertex Shader input GL instance ID holds the instance number of the current primitive, and the current primitive does not confirm this primitive. Oh wait, it doesn't say it right there, or what kind of it's an int. It's an integer. The instance ID is an integer. So it's an integer. So basically I have to come up with, in this case, because I'm doing 100 of them, 100 integers. So let's go like this. GLUint. And we're going to call this text offsets. Okay. So we want 100 of those. And then can we do this? Where are we at? Main? We're in main, right? Tell me we're in main. There's no other function, Jeff. All right. Freaking out about stuff. Okay, and we definitely don't need these anymore, so we're going to get rid of those. Now, the thing to do is basically just for int I equals 0, I less than 100, I plus plus, I, no, I'm just kidding. Well, that was the wrong key, wasn't it? That was the wrong key. You know the key? That was the wrong key. Okay. Kind of like a donkey, only not a wrong key. It was a donkey. No. Sorry, I'm in a weird mood, I guess. Okay, so random, what we want, text offsets I equals random 100. So that'll go 0 to 99, right? 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 Is that right? Are you telling me that's right, or are you showing me? No. Will that do it? I think that'll do. That might do it. Let's check it out. Let's just check it out. Let's just see. Okay. Okay. Oh wait, I have no way to know. No. Okay, so now we have our array basically. So we have like this. Okay. So what we're going to do is go down here to the vertex attrib pointer, vertex attrib pointer. Okay, so we're going to do another vertex attrib pointer. This is going to be our randomized texture coordinate offset thingy. Okay. All right, we're just going to get weird with it. We're getting weird with it. Pointer. Okay, this is going to be attribute number 2. There is approximately, oh wait, what? Oh, am I missing letters? I was like, how come it's not telling me what I'm supposed to fill in? Okay, the index is going to be 2. The size is going to be 1, right? Because that's position, there's 2. That's okay. So, and then the enum type. Oh, gee, I'm not sure. I'm not really sure. Perhaps we'd go to David Attenborough and find out the answer. So can I just do an int here, or unsigned int? Does it matter? I'm scared and stuff. Let's try an int. Okay, if there's any problems, just, call the locals and fill them in. Fill them in. Okay, so here's where we get the offset. Oh, how do we do that? I think it's going to be 5 times size of float plus size of that. Right? Right? Are we right? Is it right? Are you right? Is that right? Will that work though? I don't even know. Will that work? I don't know. So that's your stride, and then the pointer is going to be void star. Okay. 5 times size of float. And that's it. Rewrite the stars. Yes, I like some of that Greatest Showman stuff. Wait, or GLU int. So we're just going to add this to the stride of all of them, basically. Size of, basically. And I didn't even know you could do that. I just didn't know. I was unaware, folks. Really unaware until now. Unaware. Could you mark unaware on there? That's great. That's great. Okay, so we've enabled the vertex attribute array. We've created the vertex attribute pointer. The only thing left to do, really, is to, because we're already running instanced, is to say GL vertex attrib divisor. GL vertex attrib divisor. Thank you. Index. What am I supposed to do for index? Would that be the number? So that'd be 2. And then the divisor. I want this to change every 1, right? Not 0, but 1. Rewrite the stars. Okay, specifies the rate at which new values the instance vectors at index are presented to Vertex Shader running on divisor value of 0 turns off instancing, whereas any other divisor turns it on. Okay, so where's the other one? Matrix location. Yeah, so that's the index. That's it right there. I got it. We got it. So the index is basically this number right here, which they all match, right? They all match. They match. Okay, the next thing you want to do. Next thing you're gonna want to do. Okay. Let's go into here. And you want to add the layout. Location equals 2. Then you got to give it a name. You've got to. Jim. Okay, let's just call it int. And let's call it ATEX offset. Okay. All right. Are we good with? Is everybody good with that? I think everybody, pretty much is good with that. And it's just an integer, okay, that replaces GL instance ID down here. So I kind of want to keep this code because I really am fond of it. I'm quite fond of it. So text chord equals vec2. I know I'm silly, but just follow along. ATEX offset times. And why am I not using copy paste for this? Why am I typing everything out? Really, it just stressed me out. All right, I'm fine now. Rewrite the stars. Da, da, da. ATEX offset. Well, this should be BTEX offset because you've already used ATEX offset. Come on. No, I went like 8 days without sugar, and I just had some sugar, so I'm on a sugar high. So thank you for tuning in. Thank you for watching. It's been fun. Let's see if this works or crashes the system. No, sorry. So we save it. We go into here and run it. And what did I add a few lines and stuff, so it's gonna build and everything. Oh, and it's all screwed. Whoa, kids, that's actually beautiful, but screwed up. Beautiful, but screwed up. I think it's because of the size of the unsigned integer. Hold the show. I think we might be in trouble, kids. Get to the van, Scoob. I think it might be this right here. Because it's not a GL. And let's see. Vertex attrib pointer. I might have to look that up online because the book here, vertex attrib pointer. And yeah, I might just look it up online. Oh, I can't even read with my glasses on. Can you read with your glass? Oh, here it is. Vertex attrib. Hold up. Hold the show. Double precision. Integer vertex attributes. Oh, boy, did I screw up. Boy, did I. I misled everybody. You've got to put the I in here. Hold up. Okay, if you're familiar with the way floating point numbers work, you also realize precision is lost. The number is going to be very large, so the value range is going to be. For this reason, we have integer vertex attributes. These are presented in vertex shaders by int, IVEC, IVEC3, IVEC4, and their unsigned counterparts, uint. Okay, so, hold on, everybody. A second vertex attribute function is needed in order to pass raw integers. Whoa, these have been cooked, so. No, I'm just kidding. Raw integers into these vertex. One doesn't automatically convert everything to floating point. That is GL vertex attrib I pointer. Of course, you've got to add the I. And then behave similarly to vertex attributes. Type must be one of the integer type tokens. Okay, byte, unsigned byte, short, unsigned. Okay, GL unsigned int. So I need to change that right there too. GL unsigned. Where the heck? SIGNED. And there. Okay. Everything else is good. Notice that the parameters are identical to the vertex point. Example, the emission of the normalized parameter. Normalized parameter? Oh, did I do that? Did I put that in? That must be this one because that one's saying false to normalize stuff. Normalize You know what word I was going to use there. Okay, my bad. That might be a problem, kids. You might want to watch out for that one. And whoa, it's still messed up. All right, so I'm still not getting it right. So what's wrong? What's going on? What's happening? I don't know. I'm scared. Mom said it would work. Is this done yet? 7 minutes of torture. No. So how do we get this to work? Did I? Oh, I just lost my place too. I just lost my place on purpose. I did. Oh, hold on. Hold on.